So can we... I don't know.
So just expand it, the first three terms.
Okay.
First three terms.
Okay.
Using our quick way.
So it'd be 7 choose 0.
Yep.
7 choose 1. 7 choose 2. 7 choose 3.
We only need the first three.
Okay. And then be brackets 2 to the power of 7.
Yep.
2 to the power of 6. 2 to the power of 5.
Yep.
And then it's px to the power of... Is it?
Yep.
So be px to the power of 0.
Yep.
And then px to the power of 1 and px to the power of 2.
Yep. Let's see. So I'll do the middle one.
Okay. And then for p and x, what do we put in for that?
So just one, let's say.
Okay.
And we'll have to figure it out ourselves.
I got 128 for the first one. And 627 for the other. No, 672, sorry.
And so what things do we put after?
What do you mean?
Like we need to now put in px, whatever it might be.
Oh, right. The first one would just be the number, then the next one would be px.
Yeah.
And then the next one would be px, p squared x squared.
Well done. Okay, part B. Or maybe just for the sake of this. And so the first three terms of 2 plus px to the power of 7 are 128 plus 448 px plus 672 p squared x squared. But they only wanted the first three. Okay, part B.
Could you put it in as a quadratic, or would that not work?
No. So we got the first three terms in terms of p.
Yeah.
So what do you notice about our first term and their first term?
They're the same.
So what about second term? We're trying to find out what p is.
So would you do 2240 minus 448?
Well, basically our 448 px it should be 2240x. So those are like, it's the same thing. The first three terms are actually this, and so use that to find what p is.
Oh. So would you do 2240 divided by 448?
Yep.
And that gives you 5, so P is 5.
Well done. 448 equals 5. So P is 5. Okay. How do we now get Q?
Can we substitute P back in?
Yep.
So we could use 672 multiplied by 5 squared, which is 25.
Mm-hmm.
So 600, and then 672 multiplied by 20 gives you 168, no, 16,800. We'll do just x squared.
Yep.
Wait, so is x q? Or
No. So compare their one and our one.
as in theirs is 2,240 x.
Compare their x squared with our x squared.
They're both the same. It's qx squared, and ours is 16,800 x squared.
Yeah. So what is Q?
Q is 16,800.
Yep. You could divide both sides by x squared. So let's take a look. Yep, 16,800. And then the other one, P was 5. So it's basically, we didn't know what number P was. But when we expanded the first three terms, we got 128, 448 px, and 672 p squared x squared.
Yeah.
The actual first three terms, well, let's say first two terms, were 128 and 2240x.
Yeah.
And so the first one, they're the same, no help to us. But the second one we can use to solve for P.
Yeah.
The third one we can use to solve for Q. Any questions about that?
No.
Okay. That wasn't too bad. This is another type. Given that the expansion... okay, we have to do this one again. So let's see. The first three terms. Choose 0. So what would be the last one for this one?
Pardon?
What would be the last one for
okay,
this?
I'll do that now. $66.
And what else would we have?
Px squared. P squared x squared.
Yeah. Why was my one in the middle a negative?
Because it's not like the choose number's odd.
The power is odd.
Yeah.
Yeah, so minus px is just itself, minus px. Okay, those are the first three terms. Part B.
So we know that x squared is 6q. So if you divide 6 by 6q, it gives you q. So would you divide x squared by 6?
Oh, we don't. X squared is just, it's a variable. What did we make equal to each other for this one?
448px equals 2240x.
Yes. And so we made like term 2 equal term 2.
Yeah.
So the x1 equal to the x1. So what could we make equal here?
Minus 12px.
What would that be equal to?
X. So q.
Qx. The coefficient is the number in front of it, but we just don't know what number that is. How can you simplify this equation?
Divide by x on both sides.
Yes. What would you get?
Minus 12p equals q.
Yeah, you'll notice though we still have two unknowns, p and q.
Yeah.
Okay, so what can we do?
Don't know.
The coefficient of x squared is 6q. How can we use that?
Multiply both sides by 6.
No. Make the x squared things equal. Sorry, I left out the squared.
Pardon?
You know the way for this one? We did our x squared equal to their x squared?
Yeah.
Same idea.
But how would you make them x squared?
What is our x squared?
66p squared x squared.
What is their x squared?
6q.
Yeah, 6q x squared. And so we know that the x term is qx, so minus 12px equals qx. We know the x squared term is 66p squared x squared, and they told us that the coefficient of x squared is 6q. Those are equal. How do we simplify this one?
Can you get rid of x squared?
Yeah.
Which gives you 66p squared equals 6q.
66p squared is equal to 6q. Okay, how do we solve?
Could you divide by q on both sides?
Nope. We have...
6, sorry. Divide by 6.
Oh, you're right. We could, yeah.
Which gives you 11 equals 11p squared equals q.
Well done. Oops. 11p squared equals q. Okay, how can we find p? How can we find q?
Could you square root?
Could. Q equals minus 12p. Q also equals 11p squared. They are both equal to q, therefore
They're both the two answers.
Therefore, they must both be equal to each other.
Okay. So 11p squared equals minus 12p.
Yeah, so it's like substitution. It's like substitute that one in there or something.
Yeah.
Okay, solve. How do we solve it?
Divide by p on both sides.
I think you might lose an answer if you do that. What type of equation is it?
Simultaneous.
It's now a quadratic.
Okay.
Because it's gone from having two equations with two unknowns to one equation. The highest power of the unknown is squared.
So could you add 12 on both sides?
Yep.
And then put that into the calculator.
Yep.
So I got x1 is minus 12 over 11 and x2 is 0.
So we would have lost a 0 answer. P equals 0, but something tells me, yeah, it's a non-zero constant.
Yeah.
And so what is our answer?
P equals minus 12 over 11.
Minus 12 over 11. Oh, that's P. Now we need to get Q.
So you substitute P into 11P squared equals Q. Would that work?
Yeah. Sub it into the easier one.
Oh, okay. So you do minus 12 times minus 12 over 11, which equals 144 over 11.
Over 11. That's it. And they said it was 13 and 1 over 11. And the other one was minus 1 and 1 over 11. Same thing. Great. And so, yeah, we expand it. We get our term without x. We get our x term. We get our x squared term.
Yeah.
They tell us something about the x term. They tell us something about the x squared term. And so we use that to make two equations, and we solve using simultaneous equations.
Yeah.
Any questions about that?
Nope.
Not easy. Let's see this one. Yep, better do it. So let's say first three terms of this expansion. Qx0. So you just find the x squared one.
Okay. It's 28. It's the last one.
And so that'll be 28q squared x squared.
Yeah.
Part B.
So would it be 8qx equals minus rx?
Well done.
And then you can get rid of both x's by divided by x. So 8q equals minus r.
Mm-hmm.
And then what you do for x squared now?
Yep.
So you'd write 28q squared x squared equals x squared 7r.
Or 7rx squared, something.
Okay. You can get rid of both x squareds. 28q squared equals 7r.
Mm-hmm.
And then you can divide by 7 on both sides,
Oh yeah, you can.
which gives you 4q squared equals r.
Mm-hmm.
So then you do could you do 4q squared equals minus r?
No. Our equation 1, it's equal to minus r. Make it equal to plus r. What would it be?
Plus r on both sides.
No. Like, let's say times both sides by -1.
So would it be 8q over 1?
So, like, what would it be if it was r equals?
R equals 8q to the -1.
Just -8q.
Okay.
Yeah, just. And so, what would you do next?
Did you make them equal to each other? Like
Yeah.
-8q, yeah.
Yeah, now they're both equal to the same thing, so now they're going to be
So
equal
you'd
to each
write
other.
-8q equals 4q squared.
Well done.
And then could you divide them both by 4?
Yep.
Which gives you minus 2q equals q squared.
Mm-hmm.
And then would you just square root both sides? Would that not work?
How did we solve the previous one? What type of equation is it?
Quadratic.
Yep.
So you minus q squared on both sides, so minus q squared minus 2q equals 0.
Yep.
So r equals, wait, would it be r equals
Q equals.
q equals minus 2 or q equals 0? Both answers q equals minus 2.
Yep. Is that full marks?
They want the value of r as well.
Yep.
And r is, wait, but there's two answers for r.
Both will give you the same number.
So could you just say r equals minus 8q?
What is Q?
Oh, q is minus 2.
Yep.
So you substitute it back in.
Yep.
So r equals minus 8 times minus 2, which gives you minus 16.
Yep. And if you sub it into the other one, you get 4 times 4, 16.
Yeah.
That was -2 and 16. -2 and 16. And you did great. Yeah, make them both. This was r, this was minus r, so make them both r so they're equal to each other.
Yeah.
You did great, to be honest. That's grand. Okay, we've done enough of these things. Yep. Yeah. Okay, binomial estimation. Simple approximations for complicated functions. If the value of x is less than 1, then you can ignore larger powers. Okay, let's try this. So we need the first 4 terms.
Okay.
I think we're fine. You get the last 2, I'll get the first 2.
Okay. Is x just 1?
Yeah, for the calculator, yeah.
So the third one is 15 over 2.
Okay.
Wait, no. I calculated it wrong. 1 second. It's 45 over 16.
Okay.
And the last one is minus 15 over 8.
And what are the powers of x for these?
The second one is that. Oh, sorry, it's x. The third one's x squared. The fourth one's x cubed.
Well done. Okay. Use your expansion to estimate the value of 0.975 to the power of 10. Any idea how you do that?
No.
So let me show you the wrong answer. 0.975 power of 10. Okay, so that's a very accurate answer to many decimal places.
Yeah.
What we're practicing here is using a binomial expansion to estimate a number. Spot the difference. 0.975 to the power of 10 and 1 minus x over 4 to the power of 10. What equals what?
Pardon? Like, what do you mean? What equals what?
Eyeball it. What is the same? What must be equal to what?
They'll be wait, would they equal like the similar answers?
Basically, 0.975 to the power of 10 is equal to 1 minus x over 4 to the power of 10.
Okay.
Or 0.975 is equal to 1 minus x over 4.
Okay.
Solve for x.
Okay.
I'm just putting it in the calculator.
Yeah. I got x is 0.1.
Looks good. So x is 0.1. What do you do with that? You sub it into our expansion.
When you say expansion, which one?
So
You mean?
yeah. So it would be like so I'll just put like 0.1 saved as the answer. And so it's like 1 minus and then 10 times the answer over 4. And you could put in times 0.1 if you wanted. Plus 45 times answer squared over 16. That type of stuff. Minus 15 answer cubed. Or 0.1 cubed if you're doing it that way. Over 8. So let's see. Overall, 4 decimal places. What would that be?
4 decimal places. 0.7763.
So 0.7763. 0.763. Let me now go back this was the exact, or much more accurate value.
Yep.
But it's kind of a non-calculator thing. So 0.7763 and lots of other stuff. 0.7763. That was our expansion. So the way you can use an expansion. So why would we not go even further? It's because, let's say, I'll just do a very simple estimate. 0.1. So we stopped at to the power of 3. If I did to the power of 4, we get this tiny number.
Yeah.
And so that's why we don't bother. If we only wanted to 4 decimal places, this is so small that we just won't even. It won't make much of a difference. It's just an estimation anyway, and it's not worth the effort. So we can use our expansion by making them equal to each other, and then sub it in, and we can use that to estimate it. Okay, this is what the exam question looks like, up to and including the x cubed term. So I do first 2, you do last 2.
Okay.
1 minus 2x to the 10. 1 minus 20x, I think. Yeah, I did that a bit too quickly.
So you want me to write out the choose numbers? So like 10 choose.
Whatever you want. You do 10 choose 2.
Okay.
So this one was, I want 10 choose 0, 1, 2. No, you're doing the 2, I'm doing the 3. So they should be to the 7. Because they always have to add to 10. No, they should be to the 3.
So for x, you just put minus 2 times 1, or just minus 2?
I did the x.
Okay.
So just do x squared.
So would I write it out as 10 choose 2 squared, 1 to the power of 7, minus 2 to the power of 2?
10 choose 2 is just 10 choose 2, not squared.
Okay.
And so what do you get?
And then would it just be minus 2 squared for the last bit?
Yeah.
180.
Okay. So that's 180, and that's x squared.
Mm-hmm.
So you've done that so many times. Okay, part B.
Okay. So could you write out 0.98 to the power of 10 is equal to 1 minus 2x to the power of 10?
Yeah.
And then could you write out as 0.98 equals 1 minus 2x?
Yep.
And then could you put that into the calculator?
Yep.
I got 0.01.
Okay, what is next?
And then could you sub it into minus 1 minus 2x to the power of 10?
Yep. Nope. So
Oh, we know what x is, so it would be 1 minus 20
yeah,
x. Oh yeah, okay.
that way would give you like this, perfect answer, but we just want the
Okay.
estimate.
So I do for all of them, so for x squared and x cubed.
Yeah.
Okay. Is that 960, right?
Sorry, minus
Right.
960. Yeah.
Yeah. I got 0.81704.
And they didn't ask for an approximation or whatever. So, okay. Answer. Yeah, I think we got the same thing.
Yeah.
Let's see. 0.81704. Oh, that's the answer for part A. Where's B? A. Well, I don't have it, but I'm sure that that's correct. Great. Wonderful, wonderful, wonderful. And let me just, again, wrong answer or a bit too right would be 0.98 to the power of 10. 8 to the power of 10. So it's kind of a way for us to check our answer. So it's pretty decent. Hang on. Our answer was 0.01. Let me now do what you were talking about. If you put it into 1 minus 2 times 0.01 to the power of 10, you get the exact same thing.
Yeah.
So that's like the perfect thing, because 1 minus 2 times 0.01 is 0.98.
Yeah.
Okay. Great. Fine. How would you, after you've done part A, how would you start part B?
You would substitute it into the first x, then x squared, and then x cubed, the answer you got from part A.
And how would we get what x is to sub in?
We would need to do 1.97 equals 2 minus 3x and work out what that is.
2 minus 3x. So that's a bit different. I just want to see how the calculator handles that. I think it won't have any problem. Did you get 0.01?
I haven't done it.
All right. No, it's all right.
Okay.
They do like to use, there we go, x is 0.01.
Okay.
Yeah, I just noticed that this one looked a bit more complicated, but it's not. It's exactly the same. Same idea. 1 plus x over 4 is equal to 1.015, but it's all the same to the calculator.
Yeah.
That's the beauty of it. That looks good. Oh, hang on. Percentage error. Percentage error. The percentage error is you would find the percentage difference between the actual one, the estimate that we found, and the perfect one.
Yeah.
So you do like 1 over the other times 100.
Yeah.
To change it. But I just don't want to go through the whole thing all over again just for... I see square roots. What is this malarkey? Show that this one. Okay. Ah, yeah, I thought so. X equals root 2.
Okay.
The reason for that is because 3 plus 2x to the 4, 3 plus 2 root 2 to the 4. So literally x is root 2.
Okay.
Yeah, that's fine. That's absolutely fine. Absolutely fine. So it looks different, but it isn't different.
Okay.
I have so many questions here. This looks very weird. Probability of no fault is this. Oh, given that n is 2. N is 2. No. I know what I did here. Question 29. I went into every possible question, but they're not representative. That was the problem I noticed. Like question 51. I did every single one, but they're not representative of the actual questions. Okay, binomial estimation.
Probably between a tick and a half.
Grant. That's chapter 8. Let me just make sure that I'm skipping over anything. Yep, so we compare the x's, compare the x squareds, like make them equal to each other, and then solve simultaneously. I think we're okay for that. And then the second one was you use your expansion to estimate. So you equate them, you find what x is, and then you sub it in.
Yeah.
But you don't just put this into your calculator, because that wouldn't be an estimate. That would be something very accurate. And you don't just put it into this one, because that would be the same thing. That would be a perfect thing. I'm happy. Chapter 9?
Yeah.
Yay. Let's see. Chapter 9. Ba-da-bum. Ba-ba-da-bee. Da-da-ba-da-boo. I'm always singing. Okay, pure. Trig ratios. Okay. Welcome to hell. Welcome to hell. I'm teaching year 2 trig at the moment, and it's definitely the most difficult in year 2.
Yeah.
It's one of the most difficult in year 1 as well, is my guess. Okay, GCSE cosine rule. It's when you have 2 sides and an angle in between, or all 3 sides. You use the cosine rule. It's very similar to Pythagoras. Looks very similar, except minus this extra bit. You can prove it. We ain't proving it. Okay. But you do have to be able to remember it. Do you remember it?
No.
Let's see. Cos A is equal to, well, this one has the angle. No, I'll just use A. Oh, well, easy win. This is the C in the middle, so that's the one we're trying to find.
Yeah.
So it's the other two. It doesn't matter which one they are. A, B, and then it's... No, don't... Wait, don't... C squared. It's like Pythagoras. C squared is equal to A squared plus B squared, and then minus... the angle has to match up with the side that it's equal to. So these two have to be opposite each other.
Okay.
We don't have a diagram, but yeah. Okay, so ABC. So AC. All right. A, B, and that's the angle C.
Okay.
Right, let's try it.
So c squared equals 6.5 squared plus 8.7 squared minus 2 brackets 6.5 close brackets again 8.7 close brackets cos and then 100.
Yep.
Okay.
Oh, how did that happen? I have no idea how that happened. It's back.
I got c squared equals 137.5796089.
Okay.
And then you square root it.
Yep. Use the answer button.
Yep. So c equals 11.72943344.
Grant.
And then what would you round it to? Okay, what decimal place?
The standard is 3 significant figures.
Okay.
Which is like 3 digits, and so that's what that is. And they did the same thing, 11.7. So if they don't say, then that's what you do. But you keep your working out as accurate as possible. So you only round it like that at the very end. Do you remember the formula?
C squared.
Yep.
Equals B squared plus A squared multiplied by 2
minus 2
minus 2 multiplied by B multiplied by A and then cos C.
Well done. Okay. It doesn't matter which side is A and B. It does matter which side is C. And so find the size of the smallest angle. I don't know. We need to sketch this thing, I bet. 3, 5, 6. So we have 3. 5 will be like that. And then 6 is like that. Okay, so which angle is the smallest?
Probably top right of the triangle.
So I think that's because it's opposite the smallest side. I think that's why. Okay, so using that, which side is C squared? Which side is C?
3.
Yes. And so what are we subbing in?
3 squared equals 6 squared. Would that be right?
Yep.
Plus 5 squared minus 2 brackets 6 brackets 5 cos 3.
Capital C is the angle opposite. That's the one we're trying to find.
Oh, okay, yeah. Cos C.
Yeah.
And then we just want... we want to get cos C on the other side?
Yes. Yes, we do. Let me do something terrible. Put the whole thing in the calculator as an equation. And say a prayer. Cos X. Lucky I'm going 777. Roll the dice. Okay, so I got crazy answer. There's a reason for that. Let me just try much more normal. Shift solve 7. There's a reason for that. Let me just screenshot that thing. So that's what, 29.9 degrees. Let me take a look. 29.9. Oh, the trick is that the calculator gets the principal value, whereas what I did was I got another valid answer, because you could add 360. So it's like, I think that's like the answer plus 720, but I don't think I can retrieve that answer because it's in this thing. Shift solve 777. There's a little way I discovered to get out of this. So we did cos. You can do cos, shift cos. And so those two cancel each other out.
Yeah.
And just put in the answer. And that gets you the, math error. What did I, other way around. Shift cos, cos? Yes. Shift cos, cos, answer. Yay. And so it went from being 700 and something to just this. So it just got the principal one. Now, I suppose you're supposed to do 3 squared minus 6 squared minus 5 squared all over minus 2 times 6 times 5. And that's equal to cos C. And then you shift cos both sides when you've got this thing. Maybe it's not too difficult. Maybe we'll do that from now on. Okay. Let's see. They're going to be like this, are they? They're not messing around. Let me see this. Exam questions. Okay, so they thwarted me by doing show that question. Alright, better do this one.
Okay. So what does, so it says BAC is theta, is that theta, right? Or is that 0 or something? Is that integer?
Theta.
Okay.
Theta is like x for angles.
Okay. Okay.
How do we do this?
C squared equals A squared plus B squared minus 2 multiplied by A multiplied by B, and then multiplied by cos C.
Yeah. Sorry, say it again, sorry?
C squared equals A
That's
squared
right.
plus
That's
B
right.
squared.
Yeah,
Okay.
just making sure. Okay.
And then could you substitute the lengths in?
Yep.
So it'd be, wait, how do you know which one's A, B, and C? Like in length?
Maybe we need to sketch it. Do we? Yeah, maybe we need to sketch this. So let's just say triangle A, B, C. So A to B is 5. B to C is 8. A to C is 6. Angle BAC, so the middle letter is the important one, BAC, so that's theta.
So is 8C then?
Yeah, I never would have guessed that.
Okay. So it'd be 8 squared equals 5 squared plus 6 squared minus 2 brackets 5 brackets 6 cos C.
Yep.
And then could you put that into the calculator?
No, because you would get an answer like what I got, like 29.9 or something like that. Whereas this one, they actually want what cos theta equals, not what theta equals. So they want you to make it cos C equals or cos theta equals. So you'd have to do it manually. They did that so we couldn't just use a calculator, I think.
So can you divide by cos theta on both sides?
Keep that where that is. But let's say simplify what you can.
Okay. I got 8 squared equals 1 cos theta. Or just cos theta. I think.
How did you do that?
Well, I just simplified everything. So I did 5 squared. So I did 5
Uh,
squared, which is 25 plus
bit
36, 61. What?
Bidmas.
Okay.
So 25 plus 36 minus 60 cos theta.
Yeah.
60 is being multiplied by cos theta, so you can't add or subtract yet.
Okay. So it'd be 61. So 64 equals 61 minus 60 cos theta.
Yep.
And then could you minus 61 on both sides?
Yep.
Which gives you 3 equals minus 60 cos theta.
Yep.
And then could you divide by 3 on both sides?
We want to get cos theta by itself. Cos
So could you
theta
divide
equals.
by minus 60?
Yep.
So it'd be minus 1 over 20 equals cos theta.
And that's what we were trying to do. So 3 over minus 60 minus 1 over 20. Great. So the exam questions, they know what they're doing. They see people like me coming. But it's nice if it's a bigger question, something like that. Yeah, so they rearranged it. They got that. Let me just go back. Okay, so cosine rule is for if you know 2 sides and the angle between, or all 3 sides.
Yeah.
If it's anything else, you'd use sine rule. It's easier to use sine rule.
Yeah.
Sub in the values, you're good. And then this one, the important bit is the side and angle have to match up. The other two don't matter. And so it's like side opposite angle is how you have to do it. And so what do you give yourself for this one so far?
What would it take? It's pretty easy so far.
So far, there's a lot of overlap with what we just did with GCSE.
Yeah.
So they'll make it crazy. Just you wait. And so next topic for this chapter?
Yeah.
Any questions from you in general?
No.
All right. Well done, and I'm proud of you. We're finished chapter 8.
Yeah.
And I look forward to talking again next time.
You too.
All right. Thanks. Take care. Goodbye.
You too. Bye.
Bye.